Hello, everyone, and welcome again to another session of me programming daily, or at least I try to do it daily. And today on the agenda, drakon render again. We'll be working on a PR that I started during or after the last session. I can't really remember. And in that PR, what I wanted to achieve was to give each valent point that we insert a unique value, unique name. So CodeRabbit AI left some comments that I'm going to try and address right now. But first, let me put on some music in the background. Because music makes just everything easier. Okay, so I'm going to ignore all these comments that we may have gotten on non-Haskell files, and I see there are none of such comments, just Haskell. The parameter typo should be fixed. So let's dive into this. And as soon as we fix the feedback or we address feedback on this PR, I'm going to dive into another issue that I recently created. And the issue is about correctly linking newly injected valent points with their parents and dependents. Dependents. So that's one issue down. Here's another interesting piece of feedback. Suggesting to use a map instead of a fold, and I think this is great. I sometimes tend to overcomplicate the code by using folds, where a map would be a much more straightforward idea. There we go. So this is done. And the last one is also amazing. Update name. This is something that I forget about frequently. You can construct a new version of your value, overriding only certain properties. Record update syntax. Now let's build this. One more hlint suggestion. Okay, this is done. I hope everybody is doing well, by the way, today. It's pretty gloomy December day. It looks like everybody could use a little bit more sunshine, including myself. So this is pushed now. We're not going to wait for another code review. I'm just going to merge it. And all this effort is probably going to be wiped out in a second because I have an idea how to resolve the next issue. So we'll be working on this. I think the unique names, this is closed now. Now, I think I have an idea how to resolve this, but I'm afraid it will invalidate mostly what I have just finished implementing. However, I'm a big believer in incremental steps, so this steps, it's not future-proof, but works for now. So we might as well just commit to it and then slowly improve through continuous, frequent iterations. If I waited, I wouldn't have anything to show for my progress. And if I changed my mind and came up with a different algorithm, I would have to refactor a lot without a formal code review or commits. To me, it's just easier to commit smaller chunks that work, even though I already know that I'll be refactoring them pretty severely very shortly. Anyway, enough of this Phoenix project preaching. Let's continue to the next issue. So here, balance first slice. This will change a little bit. So before I start working on this, I'm going to close all these open files and show one of the, for example, this. This is a result of the new version of the program injecting valent points with the correctly applied unique names. But what I thought was we don't really have to give valent point names at this stage yet. We can do it a little bit later. And maybe I can show you what I mean. If only I find a graph with zeros. Okay, so this is a markdown diagram of the previously generated balanced paths for simple diagram. What is it? Simple diagram. And what I thought is, Okay, we could generate unique names at this stage before we link the newly injected valent points to their parents and their dependents, or we could give those names as we are linking the valent points with their dependents and parents. That way we would have to iterate through the list of paths just once. And not that I care too much about performance right now, but my primary motivation was that by doing so, it should simplify, again, the syntax of some functions like, for example, balance or balance single slice, I think. Let's see. Balance first slice and balance. Right now we're passing or we're stringing along this integer that signifies the next available unique name. I don't believe this is necessarily required. So first of all, we will need a new function. Let's call it just link. So this function is going to go through all these rows and columns, aka paths, in the list of paths, and it's going to check whether, so this is what I'm thinking now. It's subject to change. It's going to scan from the bottom, I think. It's going to look up the so let's start here. It's going to scan path by path, going up the stream. So we know that last icon in a path needs to be a dependent of the previous icon. And the beauty of operating like this, meaning balancing path by path, is that we simply know that if a valent point was injected, it needs to be a part of the parent's dependence. And what we also know is that it is for sure not injected yet because the parent doesn't know anything about it. So we can simply add the dependent, aka valent point name, to the list of parents' dependents without even checking if it's already present there, because we know it wouldn't be present. We've just injected it only in this path. It has a unique name in this path only. So the process of injecting it to the parent should be straightforward. Now, in order to proceed step by step, I'm not going to remove this int from the balance function yet. What I'm going to do, just to test the waters, is iterate through the list of lists and add a dummy dependent to all parents. So let's create a constant. And this is going to be just for now, a valent point. I do not intend for it to remain a valent point. I just happen to have a function that creates valent points. And let's give it name 9. Oh, sorry, maybe let's give it a name 0. Oh. Yeah, this is my biggest problem today, how to name a variable. Let's give it a name 0. So here, by doing this, we're iterating through all the rows. So in each row, we also need to fold, but we're going to fold row ACC, and in the row, we're going to do fold R. And each of these icons will be updated. So technically, maybe we could do a map following what I've just learned. Let's do a map. And here, no, we can't do a map because I'm not sure if map R exists. No, besides, I need to keep, map wouldn't work because I need to keep track of, well, maybe a map would work here in the outer fold, but in the inner fold, we need to keep track not only of the icon we're currently scanning, but also of the icon that was scanned previously in order to retain and discern its name to be added to the list of dependents of the currently scanned icon, if that makes any sense whatsoever. So I think I already have an update dependent. I already have a function like this that checks if a dependent name is present. If it is, it gets updated. So this is mostly for removing dependents from removing dependents from an icon. We also need a function called clear dependents. Reason? Well, when we start iterating through the list of paths, we know that the path number 1, this thing, needs to start with a clean slate. Which is a pretty dangerous concept. Anyway, let's not overthink it. The reason I'm thinking out loud is, yes, we can inject valent points into here. See this new valent point 0, we can inject it here, but at the same time, icon number 2 here and here no longer depends on icon 4. Sorry, icon 2 no longer has icon 4 as its dependent. So we would have to remove 4 from this icon 2 and this icon 2. But let's not worry about this yet. For now, and I don't have too much time today, for now I would be happy if we just injected a dummy dependent to every icon in the list of lists. So we need a function called add dependent. And it shouldn't be too hard. So we have the icon deconstructed like this. New dependent name. So the new function does something like this. I'm just copying the layout I can see here. It's a reasonably old piece of code, so it must have been formatted before. So dependence, we add new dependent name as new member of that collection. Let's build it. This is unnecessary. Oh, sorry. This is unnecessary. Let's not worry about this shadow for now. Oh, so here we don't really need an icon created because dependent is only a name. Let's change this slightly. This is more accurate. And once we have that new icon, we just add it to the column accelerator. Accelerator. Why do I keep saying accelerator? It's like an accumulator. Let's build it just to make sure it works. Oh, this isn't happy. fault R has an inverted order of arguments. Oh, and oh, it needs to be a list now. So this builds. So now, before we show the B paths, let's do link. And simple diagram 3. So simple diagram 3 now should have dummy injected everywhere. And it does. It's just inverted. Let's just double check if this is inverted correctly. Meaning, I know the individual icons are inverted, are in an inverted order, but are the individual paths in inverted order as well? So 1, 3. So paths are correct, just icons are not. We can probably correct it very easily. Let's try now. Looks much better. Oh, this infamous stuff is still not reflecting my changes. And now it is. 1 to 10, 1 to 10, 1 to 10, 1, 2, 3, 4. So everything has a dummy. And now I should probably start wrapping this up. So, to-dos for the next session. Okay, I think this is good enough progress for today. I'm looking forward to being able to correctly name and correctly link all the newly injected valent points. So, not the longest session today, but I feel the progress is good. I will see you during the next one. And yeah, next time I'll be linking actual valent points instead of this dummy one that I came up with for the purpose of this session. And yeah, I wish you all a fantastic Thursday, and see you soon. Bye.